Okay, we are now going to review Unit 4, Statistics. Okay, top few things that we needed to be able to remember is our definitions. We need to know what mean is, and the symbols, median, mode, range, and standard deviation. Okay, we'll talk about those in a moment. I'm just going to get you to write those down. When we talk about the mean, another word for it is the average. Okay, it is the average amount of something. There's two symbols. We can have the symbol of mu, or we can have X with a line over it. That's what our calculator gives us. So both of those stand for mean. The median is the middle number. Okay, it's the middle number in a set of numbers. If there's an even set of numbers, so there'd be two numbers in the middle, you would average them. You'd add them up and divide by 2. Okay? Who remembers what the mode is? Most common. So mode shows up the most. Okay, so mode is most. So the number that shows up the most. What is our range then? What's a range? Yeah, exactly. So you're going to take your smallest and your biggest and you subtract them. So you're going to take your biggest and you're going to subtract the smallest value. And that gives you the range. So it's the biggest number, subtract the smallest number. That's your range. So if my numbers went from 1 to 20, I take 20 and subtract 1. I have a range of 19. All right, standard deviation. What is standard deviation? Who remembers? Yep. Yeah, the increments it goes up by. So it's how spread out the data is. Okay, so this one is how spread out the data is. Okay, that's what it's talking about. So it's talking about the increments. So what is something counting by or going up by? Is it counting by 5s, by 10s, by 30s? And then we also have something called an outlier. Who remembers what an outlier is? Mm-hmm.
A number that is like far away.
Yeah, exactly. So this is a number that is, how would we say it is, a number that is a distance away from others, from all of the others, I should say, from all other numbers. So it's the number that sticks out. So if you've got the numbers 1 to 40, and then you've got a 98 in there, the 98 will be the outlier. Yeah, exactly. That's a very well said. The number that's significantly larger or significantly smaller. Okay? So it is significantly, I like those words. Significantly smaller or larger than the other numbers. Then we're going to talk about a histogram and a frequency polygon. So we have to talk about a histogram and how we create them. Has everybody got this written down? Okay, so histograms. And frequency polygons. Okay. So these are histograms and frequency polygons. So who remembers what a histogram is? You see it lots. What is a histogram? It's a bar graph with what? The bars are connected. Good. So it is a bar graph with the bars connected. Well, what's a frequency polygon then? What the heck is that thing? Yeah, it's a dotted line graph. But where do you get the dots from? On the top of each of the bars on the histogram. Good. So the frequency polygons are formed from the top of each bar in a histogram, or on a histogram, I should say, on a histogram. So here's my histogram. Okay, there's my histogram, and what I'm going to do is I'm going to make dots on the top of them. So there's a dot on the top of that one. It's got to be on the middle. Okay, the dots on the middle, and then we're just going to join the dots. Okay, so that's basically a broken line graph, dot to dot, on the top of a bar graph. Histogram, I should say, not a bar graph. Now, how would we find a missing number in a set of numbers when they give us an average? Remember how to do that? We're missing one number in a set of numbers, but they give us the average. Okay, remember how to do that? We'll do an example. We have to use a little bit of algebra for that one. So, let's take a look at that. So we're going to talk about the average, the mean, with a number missing. Okay? All right. Here we go. So, number 3. Is this number 3? Yeah, okay. This is finding the mean, or so finding a missing number when given the mean. Okay. Well, first of all, we have to count how many numbers there are. Count the number of numbers. And that becomes the number on the bottom of your fraction of what you divide by. So let me just do a little example of a set of numbers. So if I say, I've got the numbers 20, 21, 17, 6, 14, and something else, and I know my average is 15. My average is 15, and these are the numbers they gave me, but I have a missing number. I need to know how to figure that out. Okay? So that's what it's talking about. So we're going to count the number of numbers, including the missing number. So our missing number is going to be x. So now we've got mystery x. So we've got 1, 2, 3, 4, 5, 6 numbers, including x. Okay, 6 numbers. So now when I create my fraction, I've got 6 on the bottom equals the average on the right-hand side. Okay, your average is always on the right. Okay, and on the bottom is the number of data, the number of numbers. Okay, on top, we're going to have x plus everything else added together. So how much is everything else added together? 78. Check my work, please. So now what we're going to do is we work backwards. So we're going to get the 6 off the bottom by multiplying it out to the side. So if we multiply it out, it disappears on the left, so we've got to multiply it over here. And then we've got x plus 78 equals 80, I think. Is it 80 or 90? 90. There we go. Okay. Now we're back to one-step questions. All we've got to do now is take x, or sorry, the number beside x, and subtract it to the other side. So we're going to subtract 78 and subtract 78, and that's going to equal x. So how big is x? So we get x equals 12. So the missing data was 12. Okay? Now, for normalcy's sake, if I just wanted to find the average of these 6 numbers, I would take 20, 21, 17, 6, 14, and now my number 12. This is how you can work backwards to see if you got the right answer. So add those 5 numbers plus the 12, divide it by 6, and see if you get 15. You should. Okay? So we're working backwards to find the answer is what we've done. Okay, I'll let you finish writing that down, and we're going to move on. Okay, number 4. We need to talk about the normal, standard curve. Okay, that's your normal standard distribution curve. That's your bell curve. So, we need to know the regions on the bell curve. So, the mean, median, and mode are now in the middle. They're all 0 when we go to a bell curve. Okay? We have half the data on one side, half the data on the other. Remember, it is symmetrical about the mean, and that means that if you cut it in half, the left side is equal to the right side. Okay? So we've got 0.5 of the data here and 0.5 of the data here. Under the curve, it's between 0 and 1. It does not add up to 100%. Okay? Probability is not percentage. We convert it to percentage after. So if it's asking you the probability or area under the curve, it is between 0 and 1. Okay? Or they could say the area / probability under the curve is equal to 1. And that is true. It is equal to 1. Because if you add 0.5 plus 0.5, you do get 1. So the probability ranges from 0 to 1, but the whole thing, if I shaded the whole thing, it would equal 1. Okay, and that's what that's talking about. And then we're going to divide it up into its regions. So we're going to go -5 to +5. So I'm just going to give you a moment to write that down. Okay, next, I'm going to draw another curve for us. So, same idea, 0's in the middle. Now we're putting it into the -5 to +5. So we're talking about the Zedd scores. So, the Zedd scores, our outer boundary is -5, our positive boundary is +5. So, most of the data, they push to the edges and they say -1 to +1. They push it almost right to the edge. Change where I put that guy a little bit. Push it almost right to the edge. And then, and the reason is because they have a lot of data there. So if I've got 0.34 here and 0.34 here, and the left-hand side, so the side I'm going to shade, is equal to 0.5, if this is equal to 0.5, then that 0.34 better be a big spot, right? It better be really big, a big spot. All right. So now we go to -2. -2, then we go -3, and then we skip -4, and we go all the way to -5. So then we got +1, +2, +3, all the way to +5. Now we're given specific information about it. We are told that our 3 rules, there are 3 rules to this curve. The first rule is between -1 to +1. 68% of the data lie between -1 and +1. 68 because 0.34 and 0.34 give us 0.68. So that would be times 100 is 68% of the data. Then we stretch it out to -2, +2. -2 to +2 is considered 95% of our data. And then we stretch it out to -3. And we're going to do -3 all the way to +3. And now we're stretched almost right to the edge. We're at like 99.7. So they're saying roughly 99% of the data. So these are the 3 numbers that we call the 3 rules of the curve. So you've got a 68% that's called within. The word within means from -1 to +1. So it means from the negative number to the positive number. So if it says within 2, that means from -2 to +2. Within 3 means -3 to +3. Okay? And that's how much data that it's talking about. Okay?
Specific numbers.
Pardon me?
We do not specific.
No, the only ones you need to know are 68, 95, and 99, and those will be given on your formula sheet anyway, so you really don't need to memorize them, okay? But you need to understand where they are and why they push that -1 and +1 to the edge. And the reason they do is because these areas here have to equal 0.16, and this is way bigger. It's over double that. This is 0.34. Okay, so that's why this area is so much bigger than these other 2 spots. Okay, there's way less data on the left and on the right here in these other spots. Okay, so that's our main curve we're talking about. So what we do is we take normal data. So I'm going to give us a situation. We're going to do an example. Then we're going to convert the numbers to Z-score numbers. So here's our example. We're going to draw another curve. Only this time in the middle, we're going to call our middle 12. Whoops. The middle is going to be 12. -1 is going to be 10. 8. 6. 14. 16. 18. Okay. Now, this one is an example in our notes from page 18, and it's talking about a nurse records the number of hours that an infant sleeps during the day. She's recording the number of hours that a little baby will sleep. So, the mean of the data is going to be right in the middle. So we know that's our mean. What is the standard deviation of this data? So how spread out are each of the numbers? What is the difference between each number? 2, good. So our standard deviation is equal to 2 in this case. Okay? Now, if I wanted to say how much data is in between 10 and 14, how much data would be between 10 and 14? 68%. Now, how did you find that number? You remembered because we're going to change these numbers now to the -5 to +5. So this guy here would become 0. This guy here would become -1. 8 would become -2. 6 would become our -3. Over here, 14 would become our +1. 16 would become our +2. And 18 would become our +3. Okay? Now, we're going to convert them using actual Zedd scores. So, if I wanted to convert the number 10, so I'm going to say I'm going to do Zedd score of number 10. What we do is you take the x value, you minus the mean, and divide by standard deviation. You always write down as a little mini number, not like an exponent, but below. It's called a subscript. You write the little mini number of the x value you want to put in for x. So, I have Zedd score of 10 I'm finding. I'm going to put the 10 where x is. Then I'm going to put in the other numbers. So I need the mean and the standard deviation. So how big is the mean? 12. It's right in the middle. How spread out are the numbers? 2. Good. So now I'm going to get 10 subtract 12 is negative 2. I get negative 2 divided by 2, which gives me negative 1, which we already know 10 is negative 1. Okay? We're just proving it that that's how you would find with your Zedd scores. Now, the Zedd score formula, you are given the information. You're given all of the formulas. You don't even have to rearrange them. Those are given for you. Okay? So, sometimes they're going to give you all the information, except maybe they're looking for the standard deviation this time. Or they could do something where they might have the mean be the one you're looking for, but you've got the other 3 numbers. So whenever they give you 3 out of the 4 numbers, or a way to find the 3 numbers, that's a good way for you to know that it's going to be in this formula, and you've got to set it up accordingly. Okay? All right, so let's take a look at the averages and shading and see where we get there. So, it's number 5. Oh. So we want number 5, and that's going to be the area under the curve. So Zedd scores and area probability / probability. Well, we were given questions where it says, here is a diagram. Okay, example 1. They're going to give you a diagram, and they're going to say find the probability of it. So they might say, what is the probability of Z less than negative 2? Probability of Z less than negative 2. Well, we sketch. We know our zeros in the middle. Our negative 2, we're going to locate negative 2 on the edge. Now, it wants less than negative 2. So which way am I shading? The left of it or the right of it? The left, the way this points. So I'm going to be shading all of this. Okay? So now I need to find out how much information is there. And the calculator is going to tell us. So we're going to use our calculator, and we're going to go second bars number 2. Now on your formula sheet, it's going to show you second bars number 2, and it's going to show you second bars number 3. And it's even going to tell you right underneath them when you need to use them. You need to use them if you're given this, and this. And it'll tell you that. So, we want second bars number 2 because that's normal CDF. Okay? Normal CDF. Now, you're going to put a Zedd score, comma, Zedd score. Now, some of you might have upper and lower, okay? Or it might say left boundary, right boundary, or upper or lower. I can't remember which one it is. The lower is always on the left. The upper is always on the right, okay? So the left one, furthest left, goes there, and the one on the right is your furthest right. Now, so these numbers that I need to put in there, the numbers I'm putting in, what's my left boundary if I go far left here? -5. I always have to use my -5 if I only have one Zedd score given. Okay? Whenever they give you one Zedd score, you're only going to be using a -5 as one of the boundaries, or you're going to be using +5, depending on what the information wants. So in this case, we're going -5 to -2. So we're going to do normal CDF, and we're going to have -5, comma, -2. And that's going to give us the information we need. And remember, we only want the decimal to 4 decimal places. So everybody with your calculators, get them out. You need some practice on those. second bar is number 2. If you've got the upper and lower, remember this is lower, this is upper. Okay, or if it's left boundary, right boundary, that's what you put in. So you're going to go second bar is number 2, -5 is your lower, -2 is your upper. Is it lower upper? Yeah, it is. Okay. All right. What do we get for 4 decimal places? 0.0227. Then it's got a 4 and etc. It moves on. So this number right here, that 4 is the one we look at to round the 7. The 4 doesn't round the 7, so we just cut it off right there. We don't need those other numbers at the end. So if it asked us to a percentage, we would now times it by 100. So we have roughly 2.27% of data there. Okay? That's how we find the amount of data. So they might write it like this. You could see it like this. Okay? Instead of the letter P for probability, they might put A for area. Okay, you're going to see both. So our next example, example 2. We're going to have, we want the probability of -1.83 and 2.65. Now they're giving me, this is always going to be written this way for Z. They will always have those arrows. And those arrows mean between. So it wants the shaded area between those two numbers. So we would draw our diagram, locate your 0, locate your -1.83, locate your 2.65. Now remember, that's a ton of data in there. You should be over 70% at least, right? Because we've covered the 68% easy from -1 to +1, right? And we're almost at -2, +2, which is 95%. So it should be in the 90s. Let's see what we get for an area. So, for an area, if we go second bars, number 2, in normal CDF, you're going to put -1.83 as your lower, your upper is 2.65, and hit enter. And you're going to get the probability or area is 4 decimal places, 0.9624. Okay, that's what you should have got, 9624, 0 points. Okay, now remember, is it logically making sense? Should it be around 96% of the data? Yeah, because we're about -2 to +2, we're past +2. So it should be bigger than 95. All right, let's take a look at what if they give us the shaded area, but they want us to work backwards and find the Z score. Yep. Okay. There's another type I want to look at for a moment. Oh no, it's with the working backwards. Okay. So we're going to work backwards. So this is going to be number 5. Or is it 6? 6? Okay. 6 is working backwards. So number 6 is find Z scores given probability and area. So how do you find Z scores given the probability and area? Well, this is again the calculator, second bars, but now it's number 3. It's inverse norm. So we're going to go inverse norm. Now it always opens up a bracket. You're going to put your probability in there, okay? And then in some calculators you have to put (0), (1). Okay, sometimes they need that, sometimes they don't. Just check your calculator to see if it works without it. So the number we're putting in is the area. So here's my example. I've got this guy here, and I'm going to say I've got all of this shaded, and I'm going to tell you the shaded part sorry, the unshaded part. Oh, where am I at here? My unshaded part is 0.1271. That's my unshaded part. So, if I have an unshaded part, I want to find the shaded part. How can I find the shaded part if they only give me the unshaded part? What does the whole thing have to add up to?
Minus 1 by 1.
It's all going to add up to 1.0. So you're going to take 1.0 and you're going to subtract that. So we're going to take 1, subtract 0.1271. And that's going to give us the shaded area, which is going to equal 0.8729. So this is the number that we're going to stick on that blank there. So our number is 0.8729. And that's going to give us our Z score. That tells us where it's located on the graph. Now remember, if 0 is right about here, this Z score has to be a positive number because he's on the right-hand side of 0 on the number line. So you have to logically think where he's located. So when we type it in the inverse norm, what Z score do we find? 2 decimal places for Z scores always. Okay, so I'll put a little note for you here. 2 decimal places. It'll tell you in the questions. 2 decimal places for Z scores. Okay, so 2 decimal places for Z scores. What do we get for a Z score there? We're going to find that Z score. So Z equals 1 decimal 14. Everybody get 1 decimal 14? Beautiful. You did it right then. Well done. Okay. That is a wrap for what we need to do. So that's stats all in one, guys. Okay? This concludes our stats review.